Hello everyone. Hello. I know that I've kept you waiting. I had some technical trouble. That is why I had to keep you waiting. But it's great to see that all of you are really excited. It's great to see that we are about to witness the last solar eclipse of this year. Okay, so it's a unique opportunity. Solar eclipses are rare and few and far apart from each other. So it's a rare opportunity when we get to enjoy them together, and it's great that all of you are here to enjoy it with me. So before we get started with the actual eclipse watching, I do have um, I do have a primer of sorts for you guys to sort of get refreshed and know what exactly is an eclipse all about. Okay, so just give me a second. It's going to appear on your screens, and then we are going to get just a refresher of what exactly an eclipse is supposed to be about. Okay, so just a moment, everyone. Right, you should be able to see me now. Okay, something's up again. Just a moment, everyone. Now you should be able to see it, hopefully. Um, right. So we are just going to have a little primer of what exactly a solar eclipse is supposed to be just before the eclipse begins, just before it gets to its maximum level. We're going to have a little primer. So solar eclipses, they are quite simple. It's just a geometric arrangement of three objects: the sun, the moon, and the earth. It's a situation where the moon comes in between the earth and the sun, right? And casts its shadow on the earth. That shadow creates the illusion that somehow the sun is disappearing from the sky, the moon is causing it to disappear, and in place of it, there's just a black ball out there. Something similar to nighttime during the day, in the middle of the day. Specifically, I think it's about 12:27 right now. So in the middle of the day, it's going to be nighttime. Um, Again, regarding the refresher, it's kind of like this. The moon, while casting its shadow, has got multiple regions of shadow. It's got an umbra, which is the darkest region of its shadow. We've got penumbra, and we've got the earth on which it's falling. There is another region of it. We will talk about that as well. And since there are multiple regions of the moon's shadow, depending on depending on how the earth is receiving that shadow, which part of that shadow you're receiving as an observer, your experience of the eclipse will vary. So we have got multiple types of eclipses. Three major types are on your screen. We've got the partial eclipses, we've got annular eclipses, and we've got total eclipses. These are the variants of eclipses that we can experience. Again, they are dependent on the type of shadow that you are in as an observer. So this is kind of the situation that happens during an eclipse. There's the sunlight trying to come towards the earth. It's not able to reach the earth because it's being obstructed by the moon in between. As the moon obstructs it, it casts a shadow on the earth, and it's creating the illusion of the eclipse, or the effect of the eclipse. As I told you, we've got the umbra, we have got the penumbra, which is the lighter sort of shadow, and then we have got another reason in case the earth and the moon are further apart. So at times the moon is closer to the earth in its orbit, at times it's further away from the earth in its orbit. So here, if it's further apart, you can have another region of shadow called the antumbra. Okay, so these are the regions, and because of these different regions of shadow falling on the earth, we can have different variants of the eclipse. We can have total eclipses like these when you are watching the eclipse from the region of the umbra, the darkest part of the shadow. If you're watching it from the antumbra, you will have an annular eclipse where you'll see a ring around the surface of the moon, or the disk of the moon in the sky. So this ring is called the annulus, and it is an annular eclipse. And on the other side, we have got the penumbral eclipses, or the partial eclipses, where only a part of the sun will be covered up by the moon in the sky. So all of it is just a game of shadows, nothing more than that. This particular instance of the eclipse is going to be a total eclipse. So you can see a little simulation of the eclipse on your screen, um, right? So that is supposed to be the eclipse, and it's going to cover up the sun. The moon is going to come in the way of the sun, and it's going to create a total eclipse. This is not an annular eclipse, it's a total eclipse. Over here, we had that totality effect for a small amount of time, and then the moon will move out of the way again. So this is what we are expecting out of this particular eclipse. The eclipse is also not a static entity. It's not like if you're standing at one place on the earth, the whole time the eclipse will be visible. It's just for a short amount of time, because the moon casts its shadow at different parts at different times. Because the moon is also not a static entity, it's something that keeps on moving. So its shadow on the earth keeps on moving with it. If I see it from space, it would look sort of like this. Now, this time around, this particular shadow is not really going to fall on the earth. It's it's not going to fall on India. My bad. It's not going to fall on India. So we won't be able to see the eclipse from India. We'll have to watch a live stream. And this time it's going to happen at one of the most extreme places on the planet. It's going to happen near the Antarctica continent. So it's going to be visible from the Antarctica continent. Let's find out what the path of the shadow or the path of totality looks like this time around. This big circle that you can see, that's the lighter part of the shadow. As the color gets darker and darker, the darkest part is the path of totality, where you'll see a total eclipse. As we move on, we can see that a path was marked on the continent, and if I plot it out on a flat map, it would look sort of like this. So that's the path of the eclipse on the map of Antarctica. This part of Antarctica will actually get to experience the totality. The other parts, they will experience partial eclipses, not total eclipses. Okay? And if you guys remember, in our declaration that we sent you, we said that weather permitting, we will get to see the eclipse. So on your screen, right now you're seeing the cloud cover mapping of this particular area throughout the previous 2 decades. So from the year 2000, we are seeing what the cloud cover looked like in this area. So we will have to pray for good weather, and that will dictate whether we will see a clear eclipse or not. Okay. So let me just start the show. Let's just go for the eclipse and see what the state of the eclipse is like right now. Okay, so the eclipse has already begun. The first contact has already happened. This is what it looks like right now. First contact, by first contact, I mean that the disk of the moon has already started to get in contact with the sun. So this is live feed courtesy NASA, and we are seeing the eclipse as it's happening from the Union Glacier in Antarctica. As you can see, there is a slight movement. The shake or the shaky feeling of the camera is due to the atmospheric disturbances that we get when viewing something using a telescope. Okay, this is the live feed from Union Glacier, Antarctica. got a question from Seema Gupta. When will it happen in India? So the next total eclipse is actually quite far away. It's not going to happen anytime soon. So so we'll just have to stay patient about that. So the next solar eclipse is actually in April of 2023. There's quite a lot of time till then. We will have a partial eclipse in April of 2022. Okay, so while we have this in front of us, I actually have some fun anecdotes as well as some um, fun simulations coming up for you guys as well. Give me a minute; it'll appear on your screen. So since the eclipse is in such a hard to reach place, people had to go via cruise, via some hard to take transportation to actually get to the place. Okay. So right now the eclipse is in this situation. The eclipse is progressing, and we still are in the initial phases of the eclipse. We still have a partial eclipse. We are moving towards a total eclipse, and in a few minutes we will be able to see it. Okay, so we are back over here, and while we are waiting for the eclipse to progress through its ways, um, we do have something for you. This is a simulation of the eclipse. We have got this courtesy of fredsci.com, and this is what the eclipse would look like at the time of totality through naked eyes. This is the view of the eclipse naked eyes. So this was done before the eclipse came into existence. Right now, because the eclipse has not happened, this is actually a simulation of the eclipse, and this has been done using data based off of the eclipses that have happened previously. So it's just a simulation of what has happened previously. Right. Let's get back to the eclipse for the time being. It is progressing. It's progressing at a steady rate. Okay, coming back to our simulation. So this was the first simulation that we had. This is using something called the Newkirk filter, and it is a rough approximation of what the human eye might see during the solar eclipse. If I show you something similar to it at the point of totality, we are expecting to see something like this, although our feed would not show it, because this is in consideration of things that are way fainter than what our eyes can perceive. So this is developed using special equipment, and again, this is a simulation of what these fainter areas would look like during an eclipse. It's a combination of log scaling and unsharp masking techniques in order to create these images. So we have enhanced the edges, and we have taken the unsharp masking technique in order to create them. We've also got another type of image of the same event, which will bring out something else out of the same data. So we have got the wavelet path filter. This is another way of understanding the same data, and it shows us the bright loops that are out there, the bright things that are sticking out of the surface of the sun. They are not showing us um, they are not showing us the things that we had seen in the previous image. It's made to highlight streamer edges, non-radial features, bright loops. So in the corona region, whatever exists that is not faint in effect, that we can see through the wavelet path filter. Okay, so this is what it looks like. Another fun visualization that people have created is the 3D visualization of the magnetic field. So the magnetic field of the sun is quite extensive. You guys might have heard about it, but the issue with it is that it bends a lot. It's not a uniform field. It's a very random. It's a very chaotic field. So this is a 3D visualization of the field during the eclipse. You can see the field lines sticking out of the sun during this time. So this has been traced at extremely high resolution, and we have created something called the squashing factor, which is a scientific measure designed to indicate the presence of complex structuring in the magnetic field. So it's based off of that, and it's creating 3D view of the magnetic field. Again, these are also simulations of the magnetic field. You can see how the magnetic field lines are sticking out of the sun, and during the eclipse you can see a lot of the sun that was actually hidden most of the time, but it comes to the surface during the time of the eclipse because the glare of the sun is stopped for some time. All of these are the simulations of the magnetic field of the sun. Okay, let's go back to our eclipse. The eclipse is progressing at a nice pace, and we have got the eclipse approaching at least a quarter of the sun, I think, is covered up by now. Okay, while we are discussing observation of the sun during an eclipse, I want all of you to remember the first and foremost rule of watching an eclipse. You do not do it with your naked eyes. Okay, you need specialized gear in order to see an eclipse, because during an eclipse, our eyes are especially vulnerable to damage from the sun's rays. Okay, so how do you watch an eclipse? You can either use solar view goggles that are made specifically for this purpose. They cut down a lot of light coming from the sun, and they allow you to actually see the eclipse. The other thing that you can do, in case you're using a telescope, you can add a solar filter on top of it, and then you can see through the eyepiece the eclipse. The rule applies to the telescopes as well. It's not like you can see the eclipse using a telescope using your naked eyes. If you try doing that, there's a good chance of instant and permanent blindness. Also, viewing the solar eclipse without glasses, there's a chance of instant and permanent blindness. Please remember this, it's not worth taking the risk. Use solar filters, use solar view goggles in order to see the eclipse. There are a few indirect methods as well. You could use maybe a solar viewer. So solar viewers are devices that are made out of simple stuff like cardboard and paper. So you'll need very simple things like that. Take a cardboard box, make a hole on one side of the cardboard box, and then you can use a butter paper to create a projection of the sun using that hole on the butter paper. You point the hole towards the sun, look at the butter paper, and you get a projection of the sun. Another way could be using a ball projector. It's not as complicated as it sounds. There's a ball, a simple ball, any ball will work, any small ball will work. On top of it, paste a small mirror. Using the mirror, create an image of the sun on any nearby wall. Okay, you can turn it around a little bit and try to project the sun on a nearby wall. It's kind of like when you guys are in a classroom and you're playing around, you have a watch on your wrist and you use it to shine the sun in your friend's eye. It is similar to that, but instead of that, you're trying to see the eclipse using it. Since this eclipse is not really visible in India, right now we don't really need to think about any of that, but these are the general rules of eclipse observation. There are also things that you have to remember about what you don't have to do. So you can't use normal sunglasses to watch the sun. It is not allowed, it is not safe enough for you to see the sun using simple sunglasses. Why is that? It's because they do not provide enough protection to you. You cannot use X-ray films of any kind, films that are used for photographic films of any kind, any dark tinted glasses. All of these are unacceptable to see the eclipse. So as the eclipse progresses, I do have some interesting stories that are related to the eclipses. We will learn about some interesting incidences that have happened, a major discovery that was done in India using the eclipse, although it was not done by an Indian, but there is a cool story related to that. So it's coming right up. As we progress through the eclipse, I'll bring them up. That's live from Antarctica, Union Glacier. So, so as you can see, we have progressed through a lot of the eclipse. We are getting closer and closer to the point where we will reach the second contact. The second contact is when the sun's disk is going to be engulfing the whole lunar disk. So all parts of the moon are within the sun's disk. At that point, we say, and it's the second contact. So we are approaching that. It might be slightly surprising for all of you that the eclipse that was visible from the southern African area, so from South Africa, there was some part of the eclipse that was going to be visible. That has actually already concluded. So the part of southern Africa that was going to experience the eclipse, that part has already concluded. While we are still watching the eclipse over here, most of it, in fact, like some really small part of it was has happened like a few minutes back, but most part of the southern African eclipse, it has been concluded. So at this point, if you look at the footage closely at this point, you can see some structures that are not as symmetrical as you would expect out of something that looks like the sun, right? There is something that's making it not look so symmetrical, so circular. So those are the lunar topographical features. They are the mountainous or geographical features of the moon that are being projected against the sun's disk, and that is what is creating that look. These areas can also create some other phenomena like Bailey's beads. We are going to talk about what Bailey's beads are shortly, but these things can create those Bailey's beads, and there is a possibility that may happen. Eclipses have been quite important culturally, and not only in the recent years, I'm talking about way back since human history has began. Eclipses have had sort of a cultural importance because it's such a massive event, something that affects huge swaths of the earth at a time. So they have had a huge effect. And I have a little story from 585 BC. This is Turkey 585 BC, and we are looking at two forces that are in the middle of a battle. So Lydian and Medes, these are two tribes that are fighting over something, and there's a war going on in 585 BC in Turkey. At that moment, while they are in the field, they have been fighting for 6 years, battles have been raging for a long time. At that moment, an eclipse happened. So they didn't really take this into account. And when the eclipse happened, everybody is just in shock. All the participants of the war from both sides, all the warriors from both sides, they are in shock. They don't really know how to process this. So because they are in shock, an immediate truce is called because both sides they don't really know what to do in this situation. And after that truce is called, we end up with a situation um, where both sides just don't know if they should continue this war. Eventually, the truce lasts, which is surprising for a conflict that has lasted for over 6 years. The truce lasts, and it ends with a royal marriage, and the war is dissolved. So that is something interesting that happened related to eclipses over the years. Getting back to our eclipse, it's still progressing at a steady rate. Okay, so we can see that the disk of the moon has moved in quite a bit. We are quite far off into the eclipse now, and we are moving towards the point of totality. And it's the thing that has enough power to quell a conflict that has been going on for 6 years. It has the power to subdue a people that were living in peace until a, a certain explorer arrived. So you may have heard of this story before. Um, at somewhere you might have heard of it regarding Columbus. Columbus going to Americas, and in the way of going to the Americas, he gets stuck on an island called Jamaica. So currently it's called Jamaica, and he ends up shipwrecked there. He does not have any supplies. He and his crew, they are quite uh, a colorful bunch. They don't really have the skills to influence influence the people in such a way that they get a lot of support. Despite that, initially when they arrived on the island of Jamaica, they get a lot of support from the people over there. But over time, that support wanes. The supplies, the food, the drinks that were flowing freely earlier, that that stops, that is break down a little bit. And because of this, now Columbus is in a pinch. He ends up in a situation where he might have to work in order to get his food, or he might not be able to get his food at all. And his crew is also getting a bit scared of what's going to happen next. At that time, we see a situation where the knowledge of eclipses comes in handy. Now, Columbus comes from a civilized country. He is out there exploring the world. He has an almanac with him. An almanac is a book that contains details of the events, celestial events that are going to happen over the year. And in that almanac, there is the details related to an upcoming eclipse. So Columbus decides to go up to one of the chiefs of the tribes that were there around them and threaten them that they would end up getting smited by Columbus's god in case they don't listen to his demand. Now, the chief of the people, he decides not to heed to Columbus's demand. He does not mean to listen to his demand. So he says that we do not care. Whatever happens, we'll face it. Now Columbus makes a prediction that my God is really angry with you, and in 3 days' time he's going to make the sun disappear out of the skies as a warning. If you don't listen to that warning, you're done. 3 days pass. Everybody is having a good time. They do not really think that this threat is going to come true in the future, but it does because the almanac was made using calculations, and the people get scared. They obviously get scared. They are freaked out. They do not know why this could happen. The only real explanation that they have is that they have angered Columbus's god, and they are going to get smitten for this. They decide to take care of Columbus till help arrives. So this is a story where the knowledge of eclipses was exploited in a way in order to get some services from some neighbors. I've just received an interesting question. Why do we see the size of the moon and the sun as the same size in the sky? Why are the sun and the moon the same size in the sky? It's it's about the amount of space a particular object is taking up in the area of our vision. So think of it like this. Um, there's a skyscraper. When you're right next to the skyscraper seems huge. And let's say you move 5 or 6 kilometers away from the skyscraper. It has it has decreased in size by a lot if you do that. If you move even further, you might be able to measure it against your finger. Does that mean that the size of the skyscraper itself has changed? No, it's just your perspective that is changing. In this particular scenario with the moon and the sun, there's a unique thing going on. The distance between the earth and the moon and the earth and the sun is in such a ratio that um, it creates the situation where a total eclipse is possible. So the ratio is 400 times. The size of the sun and the moon, and the distance between the earth and the moon, and the earth and the sun. So the distances and the sizes are in a ratio of 400, and that creates this situation where the moon seems to be of the same size in the sky compared to the sun. And that is why totality can happen. Without this unique circumstance happening, totality situations where just enough of the sun being covered that you can see the corona is not being hidden, just the disk of the sun is being hidden. That is something unique to this particular ratio that we have in our system.
Okay, we are reaching quite close to the totality region. We'll get back to the feed shortly. I have received an interesting question just now. Why is the sun the same size as the moon in the sky? And the reason behind it is quite simple. It's similar to when we see a skyscraper. If we are close to the skyscraper seems to be really big in size. It seems like it's a building size thing. If you go away 5 or 6 kilometers away from the skyscraper, the same building will seem to shorten considerably. If you go even further, the same building will shorten even further. So, did the skyscraper itself change in size? No, it did not. This change in size is only happening on the end of of our perspective. It's just our perspective that is affecting this. The moon is way smaller than the sun. It's way smaller than the sun. It's not even funny how small the moon is compared to the sun. But the distance between the earth and the moon and the distance between the earth and the sun are in such a ratio that despite being way smaller than the sun, from our perspective on the earth, it seems larger, and it seems large enough that it can actually cover the whole disk of the sun. It's a unique circumstance on earth. I have one more interesting story before we get back to our feed. This story is of Samuel Williams. Now, I am sort of a history nut, and at times I like this stuff a lot. So, this story is from the American Revolutionary War, the war that was between um, United States and uh, the people of the United States, the people who lived in the United States, and the British. So, they had they had a war, and in that war, they were competing against each other. During that war in 1780, Samuel Williams is someone who's engaged in astronomy, and he wants to go out and observe an eclipse. He decides to do just that. But the problem is, despite going through a big part of the United States, the best place to see the eclipse lies in an area where there's active war. So he has to face a lot of problems. He gets the permission from the people who are in the battlefield, and he is allotted a separate area where he's assured that he won't be hurt during the conflict. He goes on to the battlefield. He tries to observe the eclipse, but in his expedition, because of incorrect maps of the time, because it's 1780, the maps are not that accurate. So because of incorrect maps and incorrect techniques, he ends up 50 kilometers away from the site where he would have actually seen the totality. but it was one of the first major attempts on the continent of America to see an eclipse. So it's a event that has been registered in history, especially due to the special circumstances of the war going on. So it's a especially brutal conflict, but he manages to stay safe. But instead of seeing the totality, he just experiences a major eclipse, an eclipse that has got a big coverage of the surface of the sun, but not quite as much as the total coverage. Over here on top, you can see something called Bailey's beads. So this was a phenomena that was registered by Samuel Williams in the United States, and this, as I told you earlier, is due to the presence of mountains, due to rough topology of the surface of the moon. So you can see these beads that are forming. They are streaks of light leaking between the valleys created by the lunar mountains. Okay, we are getting close to totality. Let's just switch back quickly to our eclipse and see what's going on over there. We are getting really close to the point of totality. So soon we'll have the second point of contact, and then we'll have our totality. These are the final few moments before totality. We are about to reach the point of totality, but just before that, we will have the second point of contact where the whole disk of the moon will be inside the disk of the sun. Photographing this event is actually particularly challenging because it's a high dynamic range event. You have got really bright parts, you have got really dim parts. If you remember our Samuel Williams story that we were just talking about a few minutes back, it is also particularly challenging because it's the 1780s. You can't just get a flight to wherever you want and you'll be there in maximum 16 or 17 hours. So getting to a place, there we have it. There we have got that unique glow that we talked about earlier. We are about to reach the point of totality. As the last sliver of the sun is being covered, please keep your eyes out for any of the Bailey's beads that you may spot. Okay, there we saw a bead. Those are the Bailey's beads that I told you to look out for. And there we have the moment of totality. We are just about there. There we have it. There we have the total solar eclipse. Around the disk of the sun, you can see the solar corona as it's being lit up by the sun. It's generally not visible because it's invisible in the glare of the sun. This is one of the unique opportunities when you can see it. If you were there at the place where this totality event was happening, you may even have been able to spot a number of stars, a few planets that are close by to the area of totality, and we're off. We're off the moment of totality. Reappearance has begun again. We can see that sliver of the sun reappearing. Okay, retraction of the lunar disk has begun, and we are leaving the initial stages. Um, we are leaving the final stages of the totality phase of the eclipse. The next total solar eclipse is again in 2022, next year in April. But from India, it will only be a partial solar eclipse. April 30th, 2022 will be the next partial solar eclipse, and then in October as well we'll have another partial solar eclipse. In April of 2023 there will be a total eclipse. So now we are leaving the totality phase. Okay, while the moon is still working on moving out of the disk of the sun, I have another interesting story for all of you, and this story is from British India, quite a few years back. So this is from 18th of August 1868 at Guntur, Madras state. Now that area of India is known as Andhra Pradesh, British India. So this guy who looks really amused right now, he is so amused with whatever is going on in this picture. Um, so Mr. Jansen, Mr. Jansen, you can see him over here. He is in British India at that time, and in the spectrum of the chromosphere, in the light that is coming from the chromosphere or the atmosphere of the sun, he observes that there are a few bright lines showing that the chromosphere is gaseous in nature. So we figured out that it was gaseous. And at the same time, he also witnesses a bright yellow line in that spectrum, which is measured to have a wavelength of 587.49 nanometers at the time. So in the spectrum of the sun, he finds that particular line, and he doesn't really know what's happening, but um, it is suspected that the presence of this line points towards the presence of a new element, so far undiscovered element on the earth. That element turns out to be helium. So this was the story of the discovery of helium. This is how we have come across the element helium. It was not found on earth first, it was found on the sun, in the sun, and it was found during an eclipse. So this is how we came across the presence of the element helium. This is the first observation of this particular spectral line. Surprisingly, just along with him, another researcher also came to the same conclusion with the same eclipse. So he was doing it from the UK, as far as I remember, and he was also watching the eclipse. He did the same thing, and their results arrived at the Royal Society um, at the same time. So both of them are credited with the discovery of the material of the element helium. Okay, getting back to the eclipse, I think something's up. Maybe there are a few clouds that are affecting this particular transmission. We'll have to see. So we'll have to wait for a few minutes. I guess there is some atmospheric issue, and because of that, the stream is currently on pause. In the meantime, let me show you the views from um, from the South African area. So the eclipse that happened before we started our our investigation today, our observation today. So they had used a different set of equipments for that, and it looked a bit different from what we have seen till this point. I hope you can see it on your screens. That was the eclipse that was witnessed in South Africa. Okay, I guess we are back with our telecast of the eclipse as it's happening. We are we are still in the retraction phase. So the moon is moving out of the way from the disk of the sun. So the next partial eclipse in India would be in October of 2022, somewhere around 5:30. So 25th of October, 2022, we should have another eclipse. So the next total solar eclipse in India is in 2034. An annular eclipse will be there in 2031 as well. So we have that to look forward to. But other eclipses, they mostly will be partial eclipses. Here too, if you look closely, you may be able to see the structures of the lunar mountains and the lunar topography in this image. It is possible to see that. Look at the upper upper part of it as well as the lower sides of it. Both sides have the lunar topography being projected out. We still have some time till the end of the eclipse. We are reaching the final reason, final exit of the moon from the disk of the sun. So recently, as part of our iAstronomer Club, we have had the opportunity to interact with with an international eclipse chaser. His name is Gernot Meisel. He came to the club. We had a long conversation about his travels as he went across the world and tried to study the eclipses, picture the eclipses. He told us about his amazing journeys across the world. So he went from um, Germany to Namibia. And just like him, a number of other groups have been traveling across the world just to chase the eclipses. Right now, the eclipse that you are seeing is from Antarctica, which is a pretty hard to reach place. I think National Geographic has sent out a team out there this year. It's called the National Geographic Resolution. The name of the ship is Resolution, I guess. And they are also doing the same thing. They are at the site of the glaciers and they are looking at the eclipse right now, but they will be releasing their photographs later on. Space actually has also sent out teams in the past when the eclipses were in India as well as abroad. So our teams have gone on and photographed eclipses in the past. Specifically, we had this whole competition called Helio DC, where students were selected and they had the opportunity to go along with an eclipse chasing team of researchers, of astronomers, of astrophotographers. They went out, they had the actual experience of actually doing the science themselves. So, this was a program by Space. In the year when we had the first lockdown, I guess in 2020, um, there was an eclipse and space teams went across the country. So in different parts of the country we had our people and they photographed the eclipse. It was an annular eclipse, so different from this one but still an eclipse nonetheless. Only a part of the moon's shadow was falling on the earth, and that is why you're seeing this particular way, or this particular footage right now. This is footage not from Antarctica but from South Africa. So this happened early this morning. Okay, let's try going back to our stream from Antarctica and see if we've got our feedback. I guess there's some time in getting that feedback. So let's get back to South Africa and see what's going on. I would like to show you the path of the eclipse again so that you have a greater understanding of why we did not have the eclipse in India, or why did we not experience it in India. It's because the path of the eclipse is not passing through India this time around. It's only going to go through Antarctica, so we'll just have to bend along with that. And that is why expeditions had gone on to Africa in order to experience the eclipse. Okay, we're back with our footage. The moon is about to leave the disk of the sun, and we are in the final phases of the eclipse. Since this time around it's happening in a place where the amount of wildlife is relatively limited. We only have penguins and some specifically adapted organisms living on the continent. I just want you guys to be reminded that when total eclipses happen in areas that have got a lot of population, whether human or animal, it leads to a lot of confusion. It leads to a lot of weird stuff happening. So instantly, as we approach the total eclipse and as the eclipse happens, you see that it's completely dark all around you, and it freaks out the animals and the birds around you. You'll find them really confused because their lives, they are regulated by the movement of the sun and the moon across the sky. So they freak out. They don't really know what is happening at that time. You can see birds trying to return back home because they don't understand that why did the day end at at 12 o'clock according to their biological clocks. And other than that, we also have a lot of other things that happen. We have a steep drop in temperature as the eclipse happens because a big area of the earth is not receiving sunlight that it is supposed to receive to maintain that temperature. So there's a drop in temperature as the eclipse path moves forward, or the shadow moves forward across the surface of the earth. So there's a drop in temperature, animals freak out. Other than that, you can also experience weird wind phenomena. So, as you guys know, that the wind flow across the planet is regulated by the sun's heat. At least a part of it is regulated by the sun's heat. And since that heat is being disrupted during this time, we experience that wind either may like there's a chance that the wind, if it is supposed to flow, it might stop. So something out of the ordinary does happen with the wind. Just pointing it out that the video is not in a buffering state. This is how the eclipse is progressing. So it's a bit slow, but it's still moving. Don't worry about it. Okay, there is a slight delay in the eclipse. So in the meantime, I in the eclipse footage coming in. So in the meantime, let's just talk a little about where you can get the information that I showed you today. I'll also tell you about some advanced um, simulation techniques that you can use, some simulation tools that you can use. So first up, regarding the information, I got a lot of questions about which eclipses we can see today, which eclipses uh, uh, are coming up in the future, which eclipses will be able to see from India, whether they will be total eclipses, partial eclipses, annular eclipses. So if you want to check any of this information, an and easy to use and not very complicated source is timeanddate.com. TIMEANDDATE. Timeanddate.com. Simple enough. You can just go over there and check out that website. It's very user friendly. Um, Enter the name of your city. You can find out in your city which eclipse is going to come up next. So that's a good source. Other than that, um, I came across two very interesting things. This is slightly advanced, not for the average solar eclipse watcher, but someone who plans to photograph the eclipse or is interested in the lunar limb. So there is a tool called the Solar Eclipse Maestro. You can search for it. It's only compatible with Mac systems, so that is a problem. But if you get your hands on it, and even with the Mac systems, there are a lot of issues. It has a lot of compatibility conditions that it will only work with a certain version of the Mac OS. But if you get your hands on it, if you have a MacBook and you can get your hands on it, it is capable of creating a lot of simulations, and it can predict the upcoming Bailey's beads, or what extent of Bailey's beads you would get. And how do they do that? That is done based on the data that they get from the LRO, the Lunar Reconnaissance Orbiter. It has mapped the surface of the moon. So we know a lot about where the mountains are, and we know a lot about how these objects are moving. So if you put all of that together, if you do a lot of math, you will be able to figure out what sort of Bailey's beads you're going to experience. Okay, so this is one tool that you guys can use. And there are some other tools as well. There's something called the Solar Eclipse Orchestrator. You can also check that out. But another thing that you can do with these tools is to automate the movement of your telescope. So if you have a compatible mount and you connect your computer, um, and you program it, if you write the correct script using these softwares, you can actually automate your telescopes, your cameras, and that is how the pros get it done. That is how, because at the time of the eclipse, the professionals or even the amateurs who are interested in taking photographs or studying the eclipse, they want to actually see the eclipse instead of just working their cameras or just taking photographs. So they set everything up in advance. Most of the time, in fact, when people chase eclipses, they start their planning at least a year or two in advance. Flights are booked out, hotels are booked out for the same purpose of eclipse chasing, because people have to do this in advance in order to be prepared at the moment of the eclipse. So these are things that you have to keep in mind. I told you about how space chased the eclipse previously. So we had pictures coming in from Rajasthan, we had pictures coming in from Chennai. So our teams in different parts of India, they took pictures of a previous annular eclipse. We've been to Oman. So Space has been to Oman as a part of the Helio DC project. And we have chased eclipses even using airplanes. So you guys know that the shadow of the moon is moving across the surface of the earth. So some eclipse chasers, they actually get on planes and chase the eclipse shadow. So they extend the time period of their totality. This is a way that eclipse chasers extend their totality by using airplanes to make them travel. So let's say this is my shadow and this is my aeroplane. So I'll try to catch up with the shadow using an airplane. So these are some techniques that eclipse chasers use. Okay, let's get back and let's try to find out if our feed is back from Antarctica. It should take a few minutes, but it should be back. Okay, for the time being, when we are waiting for NASA's feed to get back, let's switch over to our South African eclipse and see what happened in that one. We are closing in on the end of the eclipse, so just a few minutes left, then we'll see the final contact point of the eclipse as the eclipse ends. Okay, I guess we have reached the end point of this eclipse journey. This was the final eclipse of the year. I think that was the end of the footage from NASA. So with this, we have reached the end of today's webinar and today's eclipse. I hope you guys had fun today. We'll see